Let's consider this problem, which a year ago would have been much more academic and today is somewhat more relevant. We have a new disease, and the incidence of a disease is the number of new cases per unit time per unit population. So in this instance, for instance, this disease starts off at 2 cases per 100 million people per day. Um, and so in a population, a country the size of the US, that'd be about 6 or 7 people get it day one or day zero. All right. Begins at time t equals 0, and the incident increases exponentially. Why do disease incidences increase exponentially? Well, if it's a communicable disease, then it has a geometric or exponential progression, right? So any communicable disease um, can increase exponentially, especially depending on what this value, this K right here is. And so how would we determine the prevalence, the number of people that have this disease if each person has it for just a limited amount of time? All right, so let's throw some numbers at this. I've got I naught is 2 per 100 million. I'm going to take K to be, I'm going to make this 0.055 per day. We're going to make T the amount of time that somebody has this 30 days. So how do you figure this out? Well, um, we know how many people get it on day one. All right, let's go over here. I've got I naught is 2K. So on day 0, all right, on day 0, it's going to be uh, I naught, which is 2, times K times the day. All right, day 0, we've got this. Let me put in some dollar signs here. Okay, on day 1, all right, what happens on day 1? How many people get it on day 1? All right, day 1. Oh, I put $1 sign in I shouldn't have. All right, day 1, right? And so let's just go ahead and we'll go ahead and um, model out using Excel 30 days. Since I said in my version here, it has 30 days. Okay, so day 1, 2 people have it. Day 30, 10 new people get it. And if you wanted to, you could just look and say, okay, 159 people have this disease at the 30-day mark. All right. And you could do this with Excel, and be quite easy to just keep on doing this. And just take this on out however far you needed to do it. There's another way to think about this because that's a little approximate, but the prevalence, all right? What did I just do over here? I calculated the incidence for every single day. And then to get the prevalence, I just add up 30 days worth. All right. And we can argue about whether or not this is 157 or 159, right? Because I've actually added up 31 days. But I've added up 30 days worth. So the prevalence is the integral from when, whatever time we're at minus, and because we just was that, plus 1, right, to the time we're at, right? T minus 30 days plus 1, so we're not adding in that extra day down there. And then this is I of t, which is just I naught e to the kt dt. This integral is really easy to do. all integrals of the form e to the kt dt integrate to 1 over k e to the kt. So p of t is just going to be I naught over k e to the kt minus e to the k onto t minus t plus 1. That's our integral for the prevalence over a window that is t days long. All right. Now, if you want to know how many people have had the disease at any one point, the sum total of people that had it, well, that's just this first term. All right. P total all time is just I naught over k e to the kt. Okay, so let's look at these three questions. Once you've done, all right, how many people have had the disease at 180? Well, no. How many, what's the prevalence at T days? T days, all right? So over there, we got 159. We know we're going to be doing at T days, pull this up a little bit. At T days, we're going to be doing I naught over K times e to the t. E to the kt. K T. All right, 189. So what's the difference between these two? This is an approximation over here. Why is an approximation? We're only doing this, this is if the two people that have it here can only expose other people one time at 1 minute in the day, right? And so this is the result of, oh no, these exposures are going on all the time. So you can see there's a difference between I'm trying to add it up and pretend that it happens only once a day versus I'm doing the continuous function in Excel. So this is the total number of people that have had it at this time. All right. And let's look at another time. This is after 30 days. And as we looked at earlier, we probably need to take out oh, we need to subtract out C2 over C3 of 0, right? That first day when we started, we have to subtract out. Okay. So what's going on with this, right? How do we then look out at, say, at any point in time? And we want here, in this case, the prevalence at 180 days and the total number of people that had had it at that point. At 180 days, how many people have had it? All right, I naught over k times the exponent of k times 180 days. 180 days, 725,000 people have had this disease. All right, 725,000. At day 30, we had 153. At day 180, basically 6 months down the road versus 1 month down the road, we're at 725,000. How many people have active cases at that point? Well, if we want to know that, I'm going to just copy this. we have to subtract out C2 over C3. C3 is K, right? Now 180 minus 30 plus 1. All right, so we're subtracting out those that have already, or those that are no longer in the disease state. So you can see here, let's look at the difference here. I'm using 30 days, so it's roughly a month. In the first 5 months, 147,000 people had this disease. In the next month, another 578,000 get this disease. This is what it means to have exponential growth in the rate of disease. All right, and that's it for this problem.